All right, so next, what I want to talk about is inverse trig functions. So you learned in algebra that there are inverse functions. It undoes each function. Um, but with trig, because we are dealing with angles, there's actually some equivalent angles that produce the same values. And so when we think about trig functions, we have to be aware of the domain and the range. And that's going to become a lot more clear when we start graphing these sine, cosine, and tangent functions. But when you find the sine of an angle, which is what we've been doing so far, okay, we set that equal to a ratio, okay? So we have an angle, and the output is the ratio. Now, when we take an inverse function, so we use the inverse function, well, the input of an inverse function is the ratio. So we're going to be inputting a ratio, and the function's output, its range, will be an angle. So the output is going to be an angle, and the input will be a ratio. Okay, so you need to be aware that when you're using a calculator and the technology is giving you an answer, the output is going to be an angle. Now, these angles are affected by the domain and range of a trig function. And so we'll be exploring the graph of these trig functions later on throughout the semester, as well as the unit circle will also help us have an understanding of this. But basically, the sine function repeats itself at different points in the coordinate axis. Okay, and we can see that on a unit circle, but the inverse function set up on your calculator is always going to give you an output between here and here, basically a rotation of negative 90 degrees to positive 90 degrees. So negative 90 degrees to positive 90 degrees, the inverse function will tell you a value in between there and there. So it's one possible answer, but it's only the answer in that domain. Okay. The cosine function, on the other hand, the cosine function is always going to give you 0 to 180, 0 to 180. So its output will always be between 0 and 180. There can be angles that have that same ratio that are larger than that, but for the sine function, the output will always be between 0 and 180. And when we learn that, if this is not clear to you, when we review the unit circle, this will make a little bit more sense. Okay. And the tangent function is going to be always between negative 90 and positive 90 degrees. So there's these domain and range restrictions when we find an inverse of a trig ratio. Okay. Another way to write inverse sine, notice here I've used this little -1, this -1 sine to the -1 to represent that this is the inverse of sine, okay? And that we did that here as well. We use the inverse, is to use the word arc sine. Arc sine is also another. So some calculators have this listed. If you're having trouble finding the inverse sine, inverse cosine, or inverse tangent buttons on your calculator, you can't just raise them to the -1 power, but you need to look for the arc sine, arc cosine, or arc tangent sine. Okay, so I want to find the missing angles in this triangle. I have this triangle right here. I want to find the missing angles, and so I set up let's say I want to find angle T. Okay, well, I know that angle T, since it's T, let's use tangent. Tangent of angle T equals opposite over adjacent. Opposite of angle T is 7. Adjacent to angle T is 24. Okay? I can use the inverse tangent to move the tangent to the other side, to get rid of the tangent on the left-hand side. Okay? And so now I need a calculator, and I need to use my inverse tangent button. So inverse tangent, and I type in 7 over 24. 7 over 24. And again, make sure your calculator is set up in degrees. And we see that we get an angle of 16.26 degrees. 16.26 degrees. Now it says round to the nearest tenth. So that's just going to be t equals 16.3 degrees. Okay, so that was to find angle T. Now we want to find the measure of angle C. And again, I could use the fact that these angles should add up to be 180, but I want to use the numbers there, and we'll use that 180 to kind of check our answers. Now I don't have to use tangent. I could use tangent of C again, because I know opposite and adjacent from C, but let's imagine I am right here at C, okay? And I see that this is opposite and hypotenuse. So let's think about which function lets us use the hypotenuse. And I know that the opposite and hypotenuse is the sine function. So I can do sine of angle angle C equals opposite over hypotenuse. And I'm going to move the sine by using the inverse function, inverse sine function. And I get that I'm finding the inverse of 24 over 25, sine inverse of 24 over 25. So I'm going to go here, I'm going to type in, let's make sure we're using the right function, inverse sine of 24 over 25. And I see I get 73.74, or if I was rounding that to a tenth, that's 73.7. If I add these two angles together, I should get 90. So that's 73.7 plus 16.3. I get 90 degrees, so I know I found the right angles. And so that was to find the measure of angle C. Now, these aren't my only option. There was other options. If you're going, how did I know to use tangent? I could have also used tangent of angle C equals opposite over adjacent, so 24 over 7. I could use that, and I would have gotten the same answer. If I find the inverse tangent of 24 over 7, I get the same answer. I get 73.7 degrees. So it doesn't set up all the ratios. And if you know both the numerator and denominator, one of them will have to work. You can kind of guess and check that way by setting up ratios. Okay. You just want to know the numerator and denominator of the ratio. You don't want one of those to be missing. So example 4 is just having us find the missing angle for two examples. Okay, so here x will be inverse sine of 0.687. 0.687. So I'm going to use my calculator. Inverse sine of 0.687 equals 43.39, which is 43.4. Here, this is asking us to find the inverse tangent of 4/3. And so if I do that, inverse tangent of 4/3, I get 53.1. So there are usually a specific way. We usually always let if this is angle alpha here, then we'll make this little a, this side little a. If this is side beta here, this is side beta here, then this will be little b. If this is gamma here, then this right here will be c. And so we have this, this is usually the standard way of setting up these triangles. So if I were to tell you that the sides of this triangle were 10 and 12, we know that the hypotenuse in this case, the hypotenuse that we're missing, okay, is 12. And it doesn't matter which way I draw the triangle. And then the shortest side would be 10. I'm trying to find this missing side because it says solve the right triangle. So I'm trying to find the missing side. I want to round to the nearest tenth. So let's first of all, let's find the missing side. So we know that 10 squared plus a squared equals 12 squared. That is, sorry, let's make that b squared. That's 100 plus b squared equals 144. And we know that b squared is going to equal 144 minus 100, which is 44. If I square root that, I get b equals 4 times 11. The square root of 4 is 2, so that's 2 radical 11, but it did say round my answer. It did say round my answer, so I want to evaluate that by doing 2 times the square root of 11, and I see that that is 6.6. So I found B. All right, now let's go ahead and find the measure of angle beta. Okay, angle beta is going to be opposite of this angle right here. So this is angle beta right here. I see that I know the hypotenuse, and I see that I know this adjacent side. So I know the adjacent and hypotenuse. So ka, that's your cosine function, can be used to find beta. Adjacent over hypotenuse, and I'm just going to use the inverse cosine to find that missing angle. Inverse cosine. Inverse cosine of 10 over 12 is, now I noticed that this is 0.58, which is a really small angle. And so what I think happened is that my calculator at some point went back to default when I deleted everything. And so that I want to change my calculator back to degrees. That already felt wrong. And so now I see that it is possible that we have a small angle, but in this case, I see that it's 33.6 degrees is the angle there, 33.6 degrees. So always check. You never know when your calculator is going to switch modes. You always want to check and see if a number doesn't seem reasonable if you actually typed in everything correctly and your settings are correct. Okay, now let's find alpha. So alpha here is this angle. And I see with alpha, this is no longer adjacent. This is still the hypotenuse. The hypotenuse doesn't change. But with alpha, this 10 is the opposite side. Okay? And so I'm going to use, to find angle alpha, I'm going to use sine. Sine of alpha equals 10 over 12. Okay? Let's inverse sine that. And I see that that is going to need a calculator. Inverse sine of 10 over 12. I get 56.4 degrees. All right, so let's solve this triangle here. So I'm going to draw the triangle. And we'll set this side alpha, beta. This side is 10. This angle is 32.4. So I'm missing A, I'm missing C. So first, let's do what is beta. That is going to be 90 degrees minus 32.4 degrees, because these angles have to add up to be 180. And so right away, I see that beta must be 57.6 degrees. So the first step I did was to find angle beta using the fact that the angles add up to be 180. Next, let's go ahead and find A. Since I know angle alpha is 32.4 and angle A is opposite of that, I can use tangent of 32.4 equals opposite over adjacent. I use tangent because I knew that 10 was adjacent to this angle, and I'm trying to find the opposite side. So just labeling and looking at the picture, I see that opposite and adjacent legs. When I know those, tangent is the best option. I'm going to multiply tangent by 10 to find A. So I'm going to write 10 times tangent of 32.4, the angle that they gave me, and I see that that's about 6.3 units. Next, I want to find C. I can use the Pythagorean theorem, but if I got A wrong, then C is definitely going to be wrong. So let's say that I don't care about A right now. Just knowing these two things, I see that that is adjacent and hypotenuse. So I think maybe cosine, since ka, so ka toa, since I know adjacent and hypotenuse, cosine would be the best. Adjacent over hypotenuse. And with this case, whenever we have this case here, we can do the switcheroo. The switcheroo is not the mathematical term, but that's what I'm going to be calling it. Okay? So when we have this, when we're dividing by a variable, we can do the switcheroo, and we get C over here. It lets us flip those two. Again, I'm multiplying by C and then dividing by cosine all in one step there. There was an example earlier where I did that. And so 10 divided by the cosine of 32.4 is 8.4. 8.4. So C equals 8.4 units. we should have done divided by. So when I did the switcheroo, I have 10 divided by the cosine of 32.4, and I see that that is 11.8. So that equals 11.8 units here.